sinking feeling waiting for your computer to boot up? Yeah, me too. But what if that wait time was just 0? Today, we're going to dive into MRAM. It's this revolutionary memory tech that's making that happen. And believe me, it's creating a whole new class of computers that are, well, always on. No, really, think about it. You hit the power button and bam, your device is instantly on, right where you left it. No loading screens, no waiting around, absolutely 0 delay. It sounds like something out of a sci-fi movie, right? Well, it's actually becoming reality. Look, for most of us, a slow boot up is just annoying. Big deal. But what if you're not most of us? What if you're a Mars rover and you just had a power flicker? Or a critical controller that's stabilizing our entire power grid? Or, how about this, the safety system in a self-driving car? In those situations, that reboot time isn't just an inconvenience. It can literally be the difference between success and total catastrophic failure. And that right there is the core problem. It's something traditional memory just can't solve. So that's where this new tech comes in. It's this super elegant solution that's, well, it's changing everything. It's called MRAM, and it is the absolute key to building these always-alive machines we're talking about. Okay, so what is MRAM? Well, you know the regular RAM in your computer? Think of it like a bunch of tiny, leaky buckets holding an electrical charge. The second you cut the power, whoosh, all the buckets are empty. The data's gone. MRAM, it works completely differently. It uses magnetism. Picture a massive grid of microscopic compass needles. Once you point them north or south, they stay that way. Power on, power off, doesn't matter. That's MRAM. It literally never forgets. All right, let's zoom in a bit and see where MRAM fits in the whole memory family. You've got your standard DRAM. That's your RAM. It's insanely fast, but it's got total amnesia. Power goes off, poof, data's gone. Then you have flash memory, like in your SSD. It remembers everything, which is great, but it's way slower to write to, and it actually wears out over time. Now, look at MRAM. It's like the superhero child of the other two. It's got the crazy speed of RAM and the permanent storage of flash. But, and this is the kicker, with practically infinite endurance, it is a total game changer. So all of this gives MRAM this incredible set of superpowers. 1, it never forgets. 2, it has blazing fast access speeds. 3, it basically never wears out. And, as if that wasn't enough, it's also tough as nails. It just shrugs off things like radiation and extreme temperatures that would absolutely destroy other types of memory. This is exactly why it's perfect for the absolute harshest environments and the most critical jobs out there. Okay, that all sounds great in theory, right? But how does this amazing tech actually work in the real world? Let's take a look at the blueprint for how you build a computer that can wake up in an instant. All right, let's take your car's anti-lock braking system. When you start the car, you can't wait for that thing to boot up, right? Of course not. With MRAM, there's no long, drawn-out boot sequence. Power flicks on, a tiny bit of permanent code wakes up, and it instantly grabs the main firmware straight from the MRAM. The whole system is live, and it knows exactly what it was doing a millisecond ago. We're talking basically 0 recovery time. And the same idea works for even more complicated hardware, like FPGAs. Now, an FPGA is kind of like a blank slate for computer chips. You have to load a design onto it to tell it what to do. That design is called a bit stream. When you use MRAM to store that bit stream, the FPGA can be configured and ready to go in a blink. And the best part? You can do this over and over millions of times and never ever have to worry about the memory wearing out. But here's the thing, MRAM's advantages go way beyond just a quick startup. We're talking about building systems that are, from the ground up, just fundamentally more resilient and more secure. So, let's paint a picture. It's kind of a nightmare scenario. You've got a critical piece of medical care, say a heart monitor. It's in the middle of a super important software update. And right then, the power cuts out. Now, with traditional flash memory, that little power outage could corrupt the entire system. The whole thing. Leaving it completely useless, you've basically just turned a very expensive piece of equipment into a brick. Yeah, but not with MRAM. See, because you can write to it so fast and so reliably, the system can save its last known good state before the update even starts. So if anything goes wrong, power cut, bug, whatever, it can just instantly roll back to that safe state. They call this atomic, which basically means it's an all-or-nothing deal. It either works perfectly or it's like it never even happened. The result? 0 downtime and 0 risk of ever breaking the device. This same insane resilience also makes it a powerhouse for security. MRAM's persistence and reliability, it's the perfect foundation for building a digital fortress. You can store verified software images, making sure only trusted code ever runs. You can keep hardware designs encrypted. You can store crypto keys in a way that's almost impossible to tamper with. You're basically creating an unchangeable root of trust for the whole system.
Okay, let's step back for a second and look at the big picture here. Why are we getting so excited about a memory chip? What does all this really mean?
Well, what it means is that MRAM is quickly becoming the go-to choice in any industry where failure just isn't an option. Think about aerospace. In space, you're getting bombarded with radiation. MRAM's immunity is a lifesaver for satellite controllers. In our cars, it's that instant recovery that makes safety systems work every single time. And for our power grid, it's the ability to come back online predictably after an outage. See, MRAM isn't just another component, it's the thing that's enabling a much more reliable world. And that brings us to what might be the most mind-blowing takeaway of all. This isn't just about a better chip. We are enabling a whole new class of machine. I want you to really let this sink in. A continuously alive machine that briefly loses power. That idea, it fundamentally changes our entire definition of what a computer even is.
So that leaves us with one final thought to chew on. We've talked about cars and satellites and the power grid. But as our world gets more and more automated, from our homes to our hospitals, what's the next machine that absolutely, positively cannot be allowed to forget? The answer to that question? It's being designed right now. And you can bet MRAM is right at its heart.